The Slutsky equation relates the slopes of uncompensated demands to the slopes of compensated demands through the inclusion of an income effect. If you look at the equation 10.15 in the text, for instance, on the left-hand side we have the derivative of the uncompensated demand with respect to price. On the right-hand side we start with the derivative of the compensated or the Hicksian demand with respect to price. We then have a second term that's preceded by a negative sign. That second term is the income effect. So for instance, if the good x1 is a normal good, the income effect would be positive, which would mean that we retain that negative sign in front of it. Compensated demands are always downward sloping, so the first term on the right-hand side is also a negative term. So now let's think about what this seems to be saying. It seems to be saying that the slope of the uncompensated demand on the left-hand side is equal to a negative term, that's the slope of the compensated demand, minus some additional amount if the good is a normal good. In other words, it seems to say that the slope of the uncompensated demand is a larger number in absolute value if the good is normal than the slope of the compensated demand. But that seems to be saying exactly the opposite of what our graphs have been saying. In all of our graphs, if a good was normal, the uncompensated demand curve was shallower than the compensated demand curve, because the income effect pushed us further than the substitution effect in the same direction. To understand what's going on in the equation, we have to remember only one thing, and that is that this equation really isn't about the slopes of demand curves. It's about the slopes of inverse demand curves. Suppose we start, for instance, with the uncompensated demand curve for a normal good. If we took the income effect away and retained the same size substitution effect, we'd get the demand curve for a quasi-linear good, and that demand curve would be steeper. This would also be the compensated demand curve for this same individual, because we've taken away the income effect and retained the substitution effect, which is in fact exactly what the compensated demand curve does. If we again retain the same size substitution effect, but now add an income effect in the opposite direction, we'll get the demand curve, the uncompensated demand curve, for a regular inferior good. And if we make that income effect really big, we'll get a Giffen good with an upward sloping uncompensated demand curve. In order to move from a picture of inverse demand functions to one that has demand functions, we need to invert the axes, get the quantity to be on the vertical axis and price on the horizontal rather than the other way around. Now the thing about inverting functions like the ones we have in panel A is that inverting them keeps the sign of the slope the same, but it changes the magnitude. Steep curves become shallow, and shallow curves become steep. Here, for instance, we retain the demand function for the normal good, which started out pretty shallow in panel A, and therefore becomes steep in panel B. A quasi-linear demand curve becomes shallower now because in panel A it was steeper. Again, inverting these functions means that the sign of the slope remains the same, but steep becomes shallow and shallow becomes steep. You can see that this still says the same thing as it did in panel A. Suppose we start at the blue price, the lower price, and the price increases. We then get a substitution effect that moves us from A to B. The income effect, if the good is normal, should move us even further, which now means further up. And indeed, the blue curve for the normal good lies above point B. Thus the income effect still points in the same direction as the substitution effect, just as it did for the normal good in panel A. If the good is inferior, then the income effect should point in the opposite direction of the substitution effect. The substitution effect moves us from A to B as the price increases. The income effect should move us backwards, where backwards now means downwards because quantity is measured on the vertical axis. We therefore get a shallow, uncompensated demand curve for the inferior good, for the same reason that it was steep in panel A. And if the good is given, that income effect will push us even further down from point B, which means the given good uncompensated demand curve will now slope up just as it did in panel A. The sign of the slope remains the same, it's just the magnitude that differs. Let's return then to our observation about the Slutsky equation from the beginning of the animation. We were looking at equation 10.15 in the text, and we observed that equation seems to be saying that when a good is a normal good, the slope of the uncompensated demand curve will be a larger number in absolute value than the slope of the compensated demand curve. In other words, the slope of the uncompensated demand curve will be steeper than the slope of the compensated demand curve. Now look at panel B. The slope of the uncompensated demand curve is the same as the slope of the quasi-linear demand curve in our picture. That slope is indeed shallower than the slope of the uncompensated demand curve for the normal good. In other words, the blue curve for the normal good is steeper than the magenta curve for the quasi-linear good. That's exactly what the Slutsky equation says. Thus, once we invert our usual demand curves to give us pictures of demand functions in the way that they're phrased in the Slutsky equation, the equation conforms with our intuition.